Good afternoon, everyone, and thank you so much for joining us. My name is Emily Labus, and I'm the manager of digital marketing for Caserta Concepts. And today you have chosen to attend our webinar, An Introduction to Blockchain, hosted by our lovely panelists. First of all, Joe Caserta, who is the founder and president of Caserta Concepts. He also wrote the continual bestseller, The Data Warehouse ETL Toolkit. Joe lives and breathes data. He's been in the industry for over 30 years, and right now we're really kind of helping to spearhead the migration over to the cloud. And we are also joined by Scott Kessler, who is currently the Director of Business Development for Lo3 Energy in Brooklyn, New York. His background includes the administration of energy efficiency programs at NYSERDA, and CT Light and Power, as well as time spent at a consulting firm assisting utilities in improving their existing programs, promoting renewables, and assessing their impacts across the grid. Throughout his nearly 10 years of experience in the energy industry in New York and California, Scott has combined an engineering background with experience in business and project management to achieve success and energy savings amidst difficult regulatory environments. So without further ado, I'm going to go ahead and hand the presentation over to Joe Caserta. Please keep in mind that at the end we will try to get to as many questions as possible, but if we are unable to do so, your questions will be answered via email. Thank you.
Hi everybody, Joe Caserta. So let's talk a little bit about blockchain. Before we do though, I just want to talk a little bit about Caserta. So we are a consulting firm that just does nothing but provide technical solutions around data and data analytics. We're wholly dedicated to big data, data warehousing, data science, and cloud computing. We also help with more the softer type of consulting, management consulting. We just launched a new practice called disruption management because what we've been doing for the last few years has really been changing the way IT works, the way business works, the way your data platforms work from a technical perspective, a people perspective, and a process perspective. So, so we've launched quite a few new practices over the past few years, but all still wholly dedicated to analytics and data. And then, so we've been very fortunate, incredible visionary, forward-thinking clients throughout our 16 years in business, which are here on the screen. And since we launched into the big data paradigm, we found it necessary to partner with more of the emerging technologies out in the market, specifically AWS, Google Cloud, all of the Hadoop distributions, Databricks, which is Spark. And then also, one of the biggest challenges, especially when we talk about things like blockchain, which is completely different than the way the average business is already functioning. So helping identify what actually needs to change from an organization perspective, from a technology perspective, and then helping enable that change within the organization, identifying what could possibly be resisting that change, and then hitting each reason one by one so that we can actually move the status quo to the right and actually affect change within the organization. So blockchain. So on the screen right now, you'll see a book. It's called Blockchain Revolution by Dan and Alex Tapscott. That is, what I think is probably the best book on the market right now. And they came up with a very nice, concise definition of what blockchain is. Just to be clear, I don't consider blockchain and Bitcoin to be synonymous. Blockchain is a technology that is adaptable across many different types of businesses. It's incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions, but virtually anything of value. So what I'm going to talk about for the next few minutes is talk about how we can use it outside of the world of Bitcoin specifically. And then Scott is going to talk about a specific use case that had nothing to do with Bitcoin also. and just figure out, you know, it's very, very new to market, but figure out, can this technology actually take us to a place where we've never been before, and is it actually worthy? So so basically what it is, blockchain is, it's a NoSQL database, the way I think about it. It's very, very, very simply speaking, it's NoSQL. But instead of just storing data, you know, it actually stores contracts or programs or types of ways of communicating information in a very hard way. And those transactions are immutable. So the other thing that's very different about it is that there's no central repository. So all of the data by design, all of the information within a blockchain database is distributed across the world, essentially. So there's no central place, so which makes it very, very difficult to hack or to corrupt. It's hosted by millions of computers simultaneously. And the data is really accessible to anyone on the internet once you identify yourself. And then the other thing that makes it very, very unique is that you can commit transactions, but those transactions don't really become validated until it goes through a very rigorous process. And that process includes algorithms that are part of the application. And there are machines that are run all over the world that are called miners. And when we talk about miners, it's not really like they're mining data like you would think like a data miner. There's no human being actually looking at this or interrogating this or, you know, building algorithms for it. They're pre-built algorithms, and all the miners do is they run those algorithms on a computer. And usually they're very, very large computers. And the reason they do that is because for every transaction that you verify and validate, you actually get some money. And we'll talk about exactly how that works. So this is the process. So someone requests a transaction. That transaction is distributed across all of your peers throughout the entire blockchain network. It goes through this process where it accumulates a bunch of transactions and combines it with other transactions. And then it's collected by the miners, and the miners run the algorithms to figure out if this is a valid person and a valid transaction, which means that it hasn't been altered in any way. And once they confirm that it is absolutely valid, then it goes through and it allows the transaction to complete. Through that validation process, there is encryption processes going on. I am not a cryptocurrency expert, and this is not really a cryptocurrency type of webinar. That's maybe for another day. But what we do want to just explain here is that it is kind of in nature a self-auditing ecosystem, and the entire network as a whole reconciles every transaction that happens. You know, the group of, as they're grouped together, we have the miners, and for whatever reason, I think it's because of cost, most of the miners are found, there are actually websites, which I could send you if you're interested, that maps all of the miners all over the world, and the hotspots are in Eastern European countries and China, where they have just incredibly massive computers that have very high compute processing power, and the way it works is the first one to validate the block wins. So the bigger, faster computer you have, the more money you're going to make. So people are investing hundreds of thousands of dollars into servers that they host themselves, connect themselves to the blockchain network, and that is a way to make income, is just by running your machines to validate the blocks in the blockchain. So what excites me about this is not necessarily about transacting money. That is very, very exciting for people who are more in the banking business. But what I find really interesting about blockchain is the non-money part. It's the fact that you can actually make a contract about anything. So think about, you know, a healthcare claim, or a musician royalty payment, or anything where there is actually a transaction where eventually there is some monetary exchange, but the real trick behind it is like adjudicating a claim to make sure that it's valid to be processed, or to make sure that a record was actually sold, so that and what are all of the rules for how much the musician actually gets paid. Like, all of that can now be built directly into the database, rather than to have separate applications that are storing just the data portions. So in the blockchain world, everyone probably has heard of Bitcoin, but really to do what we think is the future of blockchain is to not use Bitcoin, but really to use Ethereum. And what Ethereum is, it's an open source version of blockchain that you can download and customize yourself. And by customize it means just create the contracts within the blockchain paradigm, so that these transactions work as if you're making a banking transaction. One difference is that when you are using Ethereum instead of using a Bitcoin type blockchain, is that there are no Bitcoins. The currency is called Ether, and Ether also has a market just like blockchain does. I think it's about 70 cents to a dollar right now, for Ether, for a unit of Ether, and that changes with the market just like Bitcoin does. So every time there's new transactions, the transactions are accumulated, and then if you validate that block, then you are awarded 5 Ether, which is a couple dollars. And then so the way this works actually is that it's all random. You cannot pick and choose which transactions you want to validate, and you really potentially don't even have the entire transaction. It may be distributed across different blocks, and definitely a block will contain multiple transactions, right? So there's no way to really interrogate exactly what's going on end to end. The collection of all of these transactions together, or microtransactions, enables the currency to be exchanged, or for the parts of the contract to actually be validated. So in the Ethereum world, there are essentially 2 ways to write code in Ethereum. One is in Python, and the other one is in JavaScript. This what you're looking at right now is an application called Solidity. Solidity is the JavaScript version of language that you would use to write some Ethereum code. If you're a Python guy or a girl, Serpent is the tool of choice. But in what we've seen out in the market, even though Caserta is really a Python shop nowadays, in the Ethereum world, we're seeing much more people using JavaScript. So I'm going to show you just a little quick example of what JavaScript does. So this is our little Hello World application. We just wrote a very simple function to display Hello World, and then within this application, you can see exactly the important thing to here. If you look to the right, halfway through how it would be deployed, is it has gas. So gas is really telling you how efficient and how much cost there is going to be associated to this execution. So writing very efficient code is actually going to cost you less money, and writing less transactions will cost you less money. So so now for the first time, you can actually quantify the efficiency of your code. And this actually says 47 million, I believe that number is, which is really minuscule. It's practically nothing. It's like air, because we're really not doing anything worthwhile. We're just saying hello world. If you go to Web3, I think it's web3.org, that's where you can find distributed apps written with Ether. And the next This little cartoon says, yeah, that's a very, very innovative approach, but I'm afraid we can't consider it because it's never been done before. So if you're working for a big organization, this is probably not foreign to you. Something that you want to move forward, but it's so nascent, it's too high risk, that it's very, very hard to get approved. Well, the good news is that blockchain isn't really all that new, and there's actually a very large market out there once you get yourself immersed into it. So, you know, if you look at the screen, BlockCipher and OpenChain and Guard Time, these are all, and the Blockchain Foundry, these are all applications out there that you can use to actually implement blockchain, Chain Reactor. You could look at these. There's a URL on the bottom that you can go look at and actually see the background across all of these different applications and products and vendors. So for, you know, the opportunities out there, I think for blockchain, I think it is very real, very worth looking at in a very serious way. I think anywhere where there's an industry dependent on a middleman to construct transactions, there's an opportunity for blockchain to help streamline those business processes. Scott is going to talk specifically about one with the energy sector, but real estate transactions, absolutely perfect candidate. Healthcare claims, musician royalty payments we talked about, any kind of supply chain transaction where you're going, you know, from business to business, moving product, I think is a good opportunity for blockchain. And if you're really interested in learning more about blockchain and you like cruises, you're in luck because there's actually a cruise to Bermuda and the Caribbean on May 25th, just in a couple of weeks, about a month away. That you can go have a cruise and just spend a few days just learning all about blockchain. And I got that cruise actually from this Business Insider Blockchain Conferences website. Feel free to go look at it. There's no interest on my part whether you do or don't go take that cruise. You may or may not see me there. But any information that you'd like beyond what I've shared, just a quick overview. If you'd like to dive deeper into any one of the topics I talked about, feel free to reach out directly. And I will send this over to Scott.
Great. Well, thanks so much, Joe. So, as I mentioned, as Emily mentioned at the start, my name is Scott Kessler. I'm the Director of Business Development here at Lo3 Energy. And I'm going to tell you today about our blockchain-based platform that is actually meant to be transacting electricity between participants in the electric grid. And the very first place we are actually doing this is in Brooklyn. So I'll first tell you about our platform and then tell you about the community we're working in. So Lo3 Energy is an energy company that is taking the well-adopted strategies around market transformation and technology adoption and applying that to blockchain and creating a platform that has never existed before in the electricity sector. So what we are really focused on is sort of this technology adoption curve. So how do you get folks to start adopting something at the early stage like blockchain for energy, and then how do you spread that out into the majority of people? Because as you can imagine, most folks do not care all that much about their electric bill, and we want to focus on bringing along the early adopters, those who've been going after solar already. A little bit of background on the energy sector here. I know, I won't go too deep into this because I know folks really want to hear about the blockchain aspects, but a little bit of background as to why we are focusing on the electricity sector. What we are seeing is that infrastructure and generation is becoming more decentralized and more distributed. So as solar, wind, and storage all increase, we are seeing huge amounts of penetration in various utility sectors. California, Germany, Hawaii all jump to mind as places with really high penetrations that are sort of struggling to adopt because the utility grid was not designed for sort of two-way flows. It was really meant for large coal and natural gas plants sending electricity through the transmission system, then to the distribution system, and finally to the end user. It wasn't really designed to have the generation located right next to the consumption. But there's a lot of benefits that come with that, and so we should be embracing it. We also see consumer demand is really what's driving this. This is not that the utilities are deciding to put rooftop solar, but rather that people are going out there and making these decisions on their own. You know, folks want to be providing their own energy. They're interested in clean and green electrons. And what we found recently is that they really want to participate in actually an energy trading marketplace. So Accenture went out there and found that 69% of consumers are interested in participating in a marketplace like that. That was way higher than I expected and way higher than anyone had seen before, because the, sort of general wisdom is that folks don't care about their electric bills, but what we're finding is that they just haven't been engaged in the right way. In the electricity sector, we used to refer to customers as ratepayers up until about 5 years ago. So it's only recently that utilities have had to start even thinking about folks as customers, let alone ones that they might want to be developing new services for. I touched on a few of these, but just to say that as people install solar, not only does it create sort of physical issues, it creates some economic issues, because utilities, their business model really is not around making profit off of transmitting energy to you. Rather, they are guaranteed a somewhere between 7 to 12% return on their capital they apply towards infrastructure. So there's always been a very large built-in incentive for utilities to build more equipment. What we're seeing now is they don't need as much equipment. However, they have the exact same existing equipment requirements to maintain. So you can imagine, as people use less energy, they get less revenue. However, their requirement on what their infrastructure stays the same. So they are really in a tough position right now and looking for new technologies that can unlock new revenue streams for them. We also see grid resiliency as a problem. So this is a shot of New York City during Hurricane Sandy when the power went out and the lower part of Manhattan lost power. So, we see that centralized systems inevitably have sort of weak spots. And if you are able to attack these substations, or for the electric grid, it's a substation, but you can imagine for a, information system, it's a data center. If you are able to disrupt the centralized point, all of a sudden, you impact many, many, many users. Similarly, Australia actually recently went through a blackout where they were trying to bring on excess amounts of wind power, and the utility grid wasn't designed for it, and it resulted in rolling blackouts. So this is not just a US problem, it's actually a global problem that's happening. Finally, the community itself is sort of unhappy with the energy options they have. So the first one they have is sort of what is their green energy? We know people here in Brooklyn who have been buying green power for 5 or 10 years now. But what they're buying when they do that is actually an environmental credit with a utility scale solar or wind farm located some distance away. And then they actually get a delivered electron. Now that electron comes from the nearest source of generation, because you can't tell an electron what to do, it follows physics. So the electron comes from the nearest smokestack, and they think they're buying green energy. And we have someone in our community, Janet, who's actually been participating in green energy for a long time. She told me she's been using more energy than she would otherwise because she thinks she's benefiting the grid and her community by cleaning things up. And we had to tell her that actually, in some small way, you are increasing the amount of pollution from the nearest smokestack. And, she was very upset to hear this. And so folks don't really quite understand what they've been buying when they get green energy. They also have been, solar owners have only been provided net metering, which is basically getting a rebate on your electric bill for the power you put onto the grid. But that doesn't accurately value where that power is put onto the grid or when it's put onto the grid. So there's all sorts of market disincentives, and we are trying to create a platform that adjusts for that. So that's what we call Transactive Grid. It's our blockchain-based platform, and it's really both a hardware and a software solution. So Joe did a good job of going through what is a blockchain. He talked about a distributed ledger. This is really just meant to illustrate that. You have various nodes in this network. Each one holds the entire history of the blockchain simultaneously, and as more information is added to it, more blocks are added. So how does this apply to the energy sector? So what you can start to do is actually start to apply the amount of energy generated and the amount of energy consumed, put that information on the blockchain, and allow transactions to occur. This doesn't have to just be energy supplied, by the way. It also could be energy that's actually being consumed by a device. So you can imagine a smart appliance saying, here's how much energy I am consuming right now, and here's how much money you would have to give me to turn off, which is basically them offering a smart contract. And you can imagine on the other side, there is some provider who is looking to either supply energy or buy a reduction in energy, because the utility grid does not care if we are adding generation or reducing demand. It just wants to stay balanced and do a transaction off of that data. That's really what we are doing here with our energy blockchain. We're not transacting currency like a lot of the financial blockchains. We are actually transacting energy and energy attributes. So what does that look like in practice? There on the left, you can sort of see those are our meters. These are revenue grade meters that are UL approved. They're installed on the customer side of the meter, and they actually serve as the nodes in the network. So we install one of these meters in each home participating, and they all speak to each other and run the blockchain across all of them. So they are sort of putting together a virtual machine that operates across all of the meters, and that is sort of where all of the blockchain computation happens. There on the right, you can see our blockchain explorer, as we call it. So if anyone wants to see the blockchain, it's usually a tough request to fulfill, but that's sort of the closest we can come to approximating what we can do to visualize the blockchain for you. One thing that's really important for us operating the electric sector is super fast block speeds. So if you've looked into anything around Bitcoin or Ethereum, you know that they sort of have longer block speeds. And as you add more information and more users in general, those block speeds tend to go up. So we had to be very particular in how we develop our own private blockchain to ensure that it stays super fast. So that's why we actually can't operate over one of those public ones. We need to use our own and develop that from the ground up, based on a lot of the same mechanisms as Ethereum, but it is a private blockchain we have developed. To illustrate what this looks like on the electric grid, you can imagine you have a prosumer, someone with solar panels, and they are adding energy onto the grid, and then you have a consumer who is consuming a certain amount of energy. So the two of them can do a transaction, but just as easily, they can begin to transact with other energy service providers or other markets. So this isn't just peer-to-peer. This is a market which enables both peer-to-peer and peer-to-traditional energy company. So there's a lot of new services that they can begin providing and start to compete with this neighborhood local energy. At the end of the day, what we want is folks really bidding on that small amount of local community green energy that we have, because we think that's the most premium product there is on the electricity market. And we think you can use a market like this to actually incentivize more investment in solar energy. So where do we think this goes in the future? I think it expands much farther beyond just energy supply. But when you start getting into demand response and turning off devices, you're actually getting into the grid operation itself. So you can imagine that not only do we have the blockchain in each building at the meter that knows what's happening in the building, but you also could imagine that each piece of the electric grid has blockchain in it as well. So we know the real-time, location-based value of energy at each intersection in the electric grid. So we can say at the substation level, what's more cost-effective? Is it turning off devices in Joe's home and Joe will get paid for that? Or is it turning on additional generating capacity upstream? We've never really had the tools before to sort of make those real-time calculations, but now with blockchain, we can do that fairly easily. Where blockchain is really the game changer is that the grid of the future has millions or billions of Internet of Things devices at grid edge. And there is no other system that can allow all of those devices to transact with one another in an efficient, secure, and transparent manner, just like blockchain. So that's really where blockchain is the differentiator here, because if we were still dealing with not that many devices, you could do this without blockchain. But the reason why blockchain is so innovative for the electric space is that we can now enable all these devices to talk to each other. So we see this resulting in an evolution of what the electric grid looks like. Once we start sort of tokenizing the data, which is getting the information onto the blockchain, it gives rise to these peer-to-peer markets that I was talking about. So you allow folks to access not only the capital of their neighbors, but the capital of traditional energy markets like the wholesale market, the day-ahead market, the ancillary services market, all of these things that large players have always had access to, but small ones have not. We think that's results in more and more people wanting to get solar, get storage, and other devices. And eventually you result in these community microgrids. So the utility grid of the future probably looks like lots of communities that most of the transactions happen internally. And then some of those communities are actually exporting power to the backbone that connects all the community microgrids, and some of them are importing power. So very different than the way it works today. So what is Lo3 Energy doing to sort of achieve this future? We are currently putting together what we call the Brooklyn Microgrid. This is a benefit corporation in the Park Slope and Gowanus areas of Brooklyn that is aimed at basically proving out the technology and the business models around the concepts I just talked about. So we're enabling peer-to-peer transactions to demonstrate how a utility grid can function using blockchain. Here's an example of what we call our President Street Sandbox, or our proof of concept. These were the first ever energy transactions using blockchain back in April 2016. It happened on a 1-block area where we had about 5 prosumers and 5 consumers, and we created basically a market for them. And this was really just to be our technological proof point. What we are doing now is actually scaling the number of users in this network. So now we have about 50 meters installed in the community, and we are working with New York State to become a legally licensed energy retailer. So what we are doing is actually going to be allowing folks to buy and sell energy with one another, as well as traditional retail through the utility bill. We see this as sort of the first of many demonstration projects for us. Brooklyn Microgrid is the one we are developing ourselves. We've done a lot of community engagement around this. We have spoken with a lot of people in the community, a lot of local governmental organizations, a lot of local businesses. And at the end of the day, we want this to be a community-owned corporation. So the community will own a majority of Brooklyn Microgrid once it's up and running. Like I said before, the consumers, they don't need to know about blockchain to participate. They need to know the benefits it provides to them, but they don't actually need to know what the blockchain is doing. So what does that actually look like to a consumer? Here's some screenshots of our app. So there in the middle, in that dashboard, you can sort of see there's a daily max cost. That's sort of where folks express what is their willingness to pay for energy. And you sort of see that wheel will change based on where their energy is coming from. So local energy community, that's in the 17 to 25% range. You see regional renewables, that's 12 to 15%. And then you have regional brown utility, 3 to 9 cents. So we want to allow folks to access the energy that's right for their economics as well as their personal values. And we think that's really important because not everyone's going to be able to get access to local clean energy, but we want to show that there is a big demand for it and drive that investment. People also can sort of express what energy sources make sense to you. There on the right, you see someone turned off coal. Maybe they're opposed to mountaintop removal or, the impacts of coal. Here on the left, you can see that you keep doing that for the different energy sources. Maybe you don't like hydro because it kills salmon, so you turn that off. And even with local energy, some folks are really big fans of combined heat and power. So that might be natural gas in your local community. Some folks might be opposed to fracking, so they don't want to support that. We want to allow you to make those choices and not dictate to you what your energy supply has to come from. There at the top, you'll see negawatts. Negawatts are basically the energy that you turn off. So that is the potential to offer in the things that are using energy in your home and get paid for that. If the price is right, what would it cost for you to sit in the dark? All of these are sort of preferences that people haven't been able to make choices around before, but now they can. See there on the left, you sort of see a list of household end uses or loads, and you can sort of see how much energy they're using. for each one in the middle there, lights is my current example, you can indicate how much does it cost for you to turn that off. That is something, that we think is a really compelling offer and makes folks not able to just think of the electric grid as something that they paid money to once a month, but something that actually can drive revenue back to them. Lastly, we want to take a look at some innovative ways to actually engage people around energy. So here you can see, a map showing you where your energy comes from, and you also can sort of indicate where places might be a good fit for solar energy. So we can turn around and approach them and say, hey, the community thinks this is a great spot for solar energy. Would you be interested? We might even have folks who are interested in providing some micro investment into that site. Here's just some slides on what does the user get. And so we are trying to sort of gamify things and make it more interesting to them. And also a very early stage rendering of sort of what does your battery consumer look like, because we want them to express at what price do you want to charge your battery, at what price do you want to discharge your battery. So as markets, you can imagine that during the day, solar power is abundant, there's a lot of it, and so the cost of energy goes down. At night, the solar panels aren't doing anything, so the cost of local clean energy goes way up. So there's a really good opportunity there for some price arbitrage for someone with a battery. So where do we stand today? We are looking to grow Brooklyn Microgrid over the next few years and have it become sort of a standalone business. We are also simultaneously looking to develop a number of other demonstration projects around the world. We've signed on some key partners already, including Siemens, and we are looking to sort of partner together to offer their sort of hardware, their existing hardware and software solutions alongside our Transactive Energy platform that I talked about here today. So we do not think this is something that is isolated to the US. Actually, most of the interest we have found is probably inbound from Europe and Australia. There simply is more interest in the blockchain there, and the utilities there are having a harder time with sort of solar. So I think it's something that will hit the US eventually, but for now, we actually are spending a lot of our time talking to folks overseas. And the one thing I'll leave you with today is just remember that these are, your electrons. So we are really looking to engage communities around this and engage people in a way that they haven't been before and provide them with new values and services. Blockchain's the key tool in doing that, but I always like to stress we don't want to forget the people involved. So thank you for your time today. I'm going to pass it back to Emily, and I guess we'll see if we have any questions.
Thank you so much, Scott and Joe. Like I said, we're going to go ahead and get to the questions now. Please keep in mind that if we don't get to yours, we will send a response via email. So our first question is, which vendors are adopting blockchain?
I could take that, I guess. So, the nice thing about blockchain that especially Ethereum is that it is open source. So you can just go to GitHub and download the code yourself and start implementing it right away. But vendors such as IBM also have a blockchain offering. So the nice thing about using a vendor, just like everything else, is that you have a throat to choke that if something goes wrong, there's somebody you can hold accountable. So, I think IBM is doing a pretty good job at, offering some of the newer capabilities out that are emerging, like Spark and on the Watson data platform, but also blockchain as well, which you can just, you can purchase either on the web or on-prem through IBM. I don't know, with Scott, it sounds like they started probably with the Ethereum open source code base, but then customized it to meet their needs. So it slightly resembles the original. And that's probably going to be an open trend too, because I think the original notion of blockchain when it was created was for financial transactions. But now that we see that there's so many other uses for it, rolling your own is probably going to become, more of the standard, based on the original Ethereum code base.
Okay, Great, thanks. This next one, Scott, I believe is for you. What prompted you to use blockchain for this project?
Yeah, so I mean, we realized that what we really needed to build was the market for all the distributed energy resources that would be coming online. And when you sort of think about what the future looks like, it's a very, very, very large number of devices. So there really didn't exist until 2014 when Ethereum came out, any sort of platform that could achieve that. And so that was really, I mean, it wasn't that we were deciding to use blockchain, it was that there really was nothing else. Our perspective on it is we think blockchain is the best tool out there right now. If another tool came out that was better, we would switch. But for now, we really believe that blockchain is the best tool to be dealing with many, many, many users all transacting with each other in an efficient, secure, and transparent manner.
Great, thanks. And then, has anyone successfully been able to hack blockchain? I like that one. Joe, do you want to take that?
Sure, I guess so. So successfully, no, but attempts, absolutely. And there's someone by the name of Ross Ulbricht, who's I guess pretty famous for actually doing this and penetrating. It was Bitcoin that he actually penetrated, and he was caught, and he is now serving life in prison.
Ooh. All right, so the moral of the story is don't try to hack blockchain, yes. Okay, and then this question is, what kinds of other use cases are we seeing outside of finance?
Yeah, so I think we covered a couple of them already. Energy, obviously, that Scott just spent time on. But also, if anyone is interested, if you ever heard of an artist named Imogen Heap, Imogen Heap, and she actually released a single called Tiny Human. And Tiny Human was actually released via blockchain, and the entire transaction was created by a company that she created. She's a musician slash technologist, as it seems, and it was deemed successful. And you can Google her and Tiny Human and read all about her and her company and the technologies that she used. So I definitely see a penetration already in the music royalty sector, energy sector. I believe that healthcare and claims are also going to be probably, if not this year, definitely next year.
Yeah, one very interesting use case we've seen pop up is actually the government of Dubai is looking to put all of its records on the blockchain in the upcoming years. So, not just specific applications, but they just want to take the entire government to blockchain. So definitely far beyond what most people are looking to, but it's pretty interesting.
Okay, great. Just before we move on to some of the other questions, I just want to get this out of the way now. We've gotten a lot asking about the slides. Yes, we are going to go ahead and put these on SlideShare, and we've also been recording this session, so the whole session will be made available after the webinar concludes, probably tomorrow. So got that out of the way. Okay. Here's another one, Scott. I believe this one's for you. What is the reliability of the microgrid? Is it the same as the large utility companies?
Yeah, so we actually are doing most of our community energy marketplace operates over the existing utility wires. So we are not actually installing any new wires. We are making use of the existing ones. So the reliability is the same. Con Edison is actually very frequently awarded for its reliability, so it's not usually a problem here. But as climate change changes the environment, we are seeing storms that used to be every 50-year storms every 10 years. So you can be as reliable as you want as a utility, but when a hurricane like Sandy comes through, it's almost inevitably going to knock out power because of the impact it has. So I wouldn't really ding the utilities for the loss of power. It's more the changing environment. So part of Brooklyn Microgrid is actually a physical microgrid as well that would be able to create an electrical island. But the members of the community energy marketplace are not restricted to that sort of 5x5 physical microgrid area.
Okay, great, thanks. All right, here's another one. Joe, I think this one's probably going to be for you. I heard blocks are not very scalable. As the blockchain grows, it takes longer to process. Is that true?
That is true. And actually, Scott touched on that a little bit. And that is also another reason why I think, the nice thing about having Ethereum being open source is as people in the community start making it faster and better, hopefully they'll contribute it back to the community, the Ethereum community, so that everyone could take advantage of the better, more efficient code base. But right now, there is definitely scalability issues. What that threshold is, I'm not really sure. Probably depends on your specific code and your specific use case.
Okay, great. Moving along, Scott, this one's going to be for you. Are Lo3 customers physically exchanging electrons and money?
So I would say they are. So the way the electric grid works is that we don't track any electrons. So right now, generators send out energy and lots of consumers consume it. And on a monthly basis, your bill basically acts as a settlement process to compensate folks who generate electricity. But we don't know exactly where the electrons you consumed came from. This operates in the exact same manner. So except now, instead of a few small generators, we have lots and lots of little generators who need to be settled with lots and lots of consumers. So it's sort of, I can't say they are sending each other electrons necessarily, but those are the electrons you are paying for, if that makes sense. As far as the financial portion, like I mentioned, we are an energy blockchain, not a financial blockchain. So the payments happen automatically through third-party payment providers. Those payment providers could be, they could be PayPal, they could be Square, they could be even new blockchain-based payment providers like actually Circle. So we are sort of agnostic to that. At the end of the day, my guess would be most people on the electric grid will not be using a cryptocurrency based on blockchain to pay their electric bill. But if that's the way things go, that is not a problem for us.
Okay, great. All right, next question. What enables blockchain to handle the scale of many devices consumers exchanging information that another web service can't?
Scott, yeah, that sounds like something you touched on earlier. Yeah, go for it.
Yeah, so the idea, what enables it is that each node in the blockchain has the entire history of all the blocks that came before it. So they know all of the operational conditions, and when new information is added to the chain, they get it at the same time as everyone else. So you do not have to go to a sort of centralized location to determine whether or not a transaction is valid. You can validate the transactions between all the nodes in the network. So that's sort of where, the traditional financial standpoint is banks. Banks get removed from the situation because you do not need to ask a bank whether or not I have the money and you have an account to accept it. We know that information already. So the same thing is true for what we're doing here with energy, but it's not banks, it's sort of energy retailers and utilities.
Okay, great. We do still have a few more questions, but I think that's about all the time we have for today. So again, we are going to get the answers to those questions out to you via email. And if anyone else thinks of anything that they want to ask, feel free to follow up with me via email. Thank you so much to our panelists, and thank you all for coming out today.
Thanks, Emily.
Thanks. Bye, guys.